You examine 2 bunnies or rabbits or bunny rabbits every month, and what you see is that the first month they meet, and then the second month they mate, and then after that they reproduce. So here's how it works. Month 1 they meet. Then at month 2 they've met, but then they mate. And then at month 3, they have mated, so they have babies after that. So what's the point? So this is a guy named Leonardo Bonacci who was posed this question. So let me take a little side note here. What kind of guy forces 2 bunny rabbits to mate after 1 month after they met, or forces them to have 2 kids every time they reproduce? But who am I to judge? So what Fibonacci said was, at month 1, there was one pair of bunnies, and at month 2, there's a 1 pair at month 1, and at month 2, there is still 1 pair, but they mate. And then at month 3, they have babies, so now there's 2 pairs. So at month 1, they have 1 pair, month 2, they have 1 pair. So this is the sequence that you're left with. It's like 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and 89. And these are called the Fibonacci numbers. Now these have some pretty cool properties, such as if you add the previous 2 numbers, you can get to the next number. So let me show you. For example, there's 1, 1, 2, 3, 5, 8, and then you have that whole example I showed you in the beginning. So if you take 1, and you take 1, and then you take 2, for example, 1 plus 1 equals 2. If you take 2, 3, and 5, then you get 2 plus 3 equals 5. Simple enough. There's also a really cool other property. So take a 4-number chunk and then multiply the outer ones. Multiply the inner numbers as well, then multiply that inner number by 2. So both of these numbers are part of a Pythagorean triple. Then use the Pythagorean theorem to find the hypotenuse. So if you take, let's say, this little set here of 4 of the Fibonacci numbers, then you can take the outer ones, like 1 and 3, multiply them together to get 3. Then you take the 1 and 2, and then you multiply those. So 1 times 2 equals 2, but then you have to multiply that by 2. So you get 4. So your 2 legs are 3 and 4. And then to find the third leg the hypotenuse of a right triangle. So let me just draw this out here. You have 3, you got 4, and then you got x. So you have 3 squared plus 4 squared equals x squared. 3 squared plus 4 squared is just 9 plus 16 equals x squared. 25 equals x squared. And then if you square root it all, you get 5 equals x. So your hypotenuse, therefore, is 5. But that's not all. So the area of a triangle is the base times height divided by 2, right? So that means if you take the 3 times 4 and you divide it by 2, which is just 12 divided by 2, which is just 6, and then multiply the 4-number chunk that you chose in the beginning. So I chose 1 times 2 times 3, you get 6. Now here's another cool property. Arrange the Fibonacci numbers 1 through 9 in this order into a 3x3 grid. Then what you could do is if you multiply each row, and then if you multiply each column, each column together, and then if you add all those numbers up, you would, in theory, get 400 on both sides. So let's try that. So 13 times 8 is just 104. 34 times 5 is 170. And 3 times 2 times 21 is just 6 times 21, which is just 126. So 104 plus 170 plus 126 equals 400. And then if you take 34 times 3, then you would get 90, and then, sorry, I have to multiply this in my head, so you get 102. Then after that, if you do 5 times 2 times 13, you get 130. Then if you do 21 times 1 times 8, you get 168. And so 102 plus 130 plus 168 does indeed equal 400. Yeah. It also makes a pretty spiral. If you take the 1, 1, 2, 3, 5, 8, 13, 21, 34, and 55, and if you make each one the dimensions of it, so let's say the 8 would be an 8 by 8 thing, then you could make a pretty spiral just by arranging these in order. You know what they say, be fair or be Fibonacci. Thanks for liking, watching, commenting, and subscribing.